Dear students, in previous class the expression for current and current density in terms of drift velocity, derivation of Ohm's law and expression for resistance. So we know the drift velocity of the conductor. So you know the drift velocity that is Vd is equal to E by m into tau in previous class. Okay, so here E is the small e is the charge on the electron and m is the mass of electron and E is the applied electric field and tau is the relaxation time. So here if we apply, for example, if V is the applied potential, if V is the applied potential difference across the conductor and L is the length of the conductor, in previous class we already discussed, then the electric field inside the conductor, so and L is the length of the conductor, so that means electric field E is equal to V by L. So electric field E is equal to V by L. Now, but we know the drift velocity Vd is equal to E small e into capital E by m into tau. Okay, so by using these two, so in place of capital E, okay, I am substituting V by L, that is E into, so in place of E I am substituting, that is E capital V by ml into tau. Okay, so let us consider this is equation 1, this is equation 2. From equation 1 and 2, I am writing this expression drift velocity. Okay, so let us consider this is equation 3. But we know the current in terms of drift velocity, and we know current in terms of drift velocity Ne into A Vd in previous class, from previous class. So here also you know N is the number density, that is number of free electrons per unit volume, and E is the charge on the electron, and A is the area of cross section of the conductor, and Vd is the drift velocity. Okay, so Vd is the drift velocity. From this expression I can write, so Vd is equal to I by NEA. Okay, so let us consider this is equation 4, equation 4. So but we know the drift velocity and here also the drift velocity. So if you equate these two things, two equations, so equation 3 and 4, from equation 3 and 4, so you can write EV by ml into tau is equal to I by NEA. Okay, so if you simplify these terms, I can write here V is equal to, so ఈ remaining terms అన్ని అటువైపు తీసుకెళ్ళండి, V is equal to, so I ని పక్కన పెట్టేద్దాం, you can write, so it is ml by n e square a tau. Okay, so this is the relation you will get when you equate these two formulas. So this formula is looking like V is equal to IR from Ohm's law. So this is a mathematical form of Ohm's law. Okay, so here you can write R is equal to ml by n e square a into tau. So this is the resistance of the conductor. So if this is the resistance of the conductor, so here L is the length of the conductor and A is the area of cross section of the conductor. So that means L and A depends upon the dimensions. Okay, that means geometry, that is shape of the object. So I can write here L and A రెండిని separate చేస్తున్నాను, that is m by n e square tau into L by A. So m by n e square tau, these are the constant values. So these values does not depend upon the size of the conductor. So these values L and A, these values indicates the geometry of the object, geometry of the conductors. So that's why I can write here R is equal to, so some constant I am writing, this is some constant into L by A. So this is the relation, that is resistance is equal to rho L by A. So L, rho is the resistivity. So this resistivity is equal to M by N E square tau. So this is resistivity, and this is resistance. This is resistance. So remember, resistivity and resistance, these two are two different words. Okay, so this resistance depends upon the length of the object, area of cross section of the conductor, length of the conductor, and also nature of the material, that is rho. But here rho is purely, that is the nature of the material. So for rho values for different elements like gold, silver, platinum, copper, for different elements having different resistivity. Okay, but the resistance is depends upon the size. So how much, what is the length of the conductor, what is the area of the conductor. So this is a major difference between resistance and resistivity. Okay.